Okay. It should be back up. I don't know if we can do another screen. We might be able to do another screen share in addition to.
Oh, it's much better now.
Yeah.
There's still a couple of seconds lag, but it's not like half a minute.
Yeah. So this is cool. I liked reading your library. I didn't know about it until earlier like this morning, because like
Okay.
I haven't looked at anything in the Lean ecosystem like basically ever.
I think the Coq and Lean is a bit separate, two separate worlds, and I don't know how much people talk.
Do you know how much progress there is in like separation logic in Coq? I know in Lean. Because things like Iris and VST are like so far along in Coq that like I can't imagine like Lean.
Okay,
Yeah, I know
what's
that
so far
all
along?
the software verification, like this low level stuff, is
Yeah, we're talking about separation logic,
Oh.
and about how like I was talking about separation logic and about like VST and verified software toolchain and Iris. They're both like super far along for
So there is
as
oh,
projects.
So there is a port of Iris to Lean. So here is Iris Lean, and it looks like there's some activity 5 days ago. So it looks like it's someone. Oh no.
Oh, cool.
Yeah, but okay. Last comment is 5 days ago, but then the previous one is 6 months before that. So I don't know how active that is.
That update was just to update the tool chain.
So is the guy at ETH working on Iris, or that's different project?
I don't actually know. I mean, I know Iris is very like MPI, like it says it right there in the URL, Max Planck Institute, which like has a bunch of universities affiliated. I bet you there are ETH people at Iris, but like, I don't know if not to me. I haven't heard of it off the top of my head like a super strong. I definitely met some Irish people in Switzerland, and I don't remember if they said ETH or one of the other universities in Switzerland. That's the thing for me.
Oh, it's in there.
Oh, lead for property testing. There is, okay, LSpec. Okay, here we go. Because I have played a little bit with the Quick Chick book. Quick Chick is guess what it is.
I know what it is.
You know what Quick Chick is?
It's actually spelled with the I. And not
It's spelled with an I, yeah.
Then no, I don't know.
Okay, so Quick Check is Haskell's property test library, and they made a Coq property test library.
Oh.
And they called it Quick Chick because chick is like a word for like a baby chicken,
Yeah.
and cock is a word for chicken in French. So it's like funny. Anything like Quick Check, you know. Slim Check. LSpec. Okay, so what's LSpec?
That's the one you're just looking at.
Yeah. But I forget what HSpec is. I forget if HSpec is like a competitor with Quick Check or if it's something weaker or something stronger.
It's like Nest X or something.
They're saying Slim Check, yeah. I enjoyed the Quick Check book. It's a good book. I got like over halfway through, I think, before getting distracted.
Nest.
Nest Core? Nest Unit?
I clicked on core.
I've heard a little bit about Tasty.
But it's not. No, it's only something on top, doesn't it?
Well, nest is something on top of tasty, is what it said. Or,
It's supposed to be like tasty.
oh, like tasty. Never mind. Is nest also for Haskell?
No, this is for Ranger,
Um.
which is why we're looking at it.
I learned a lot today, y'all.
Scope extension to write a test tree. That's an idea for an ML model. Have it solve problems by not recursively, by repeatedly rewriting them into ever more specific DSLs. Because just think how lean you have a shitload of DSLs, and most people I imagine would kind of hate that in one sense because there's just so many of them. But you can have a whole continuum of DSLs and expressivity. So you just try to solve a problem by running it through like a base change of all of the DSLs at once.
I mean, it'd be one thing to transform the stack of DSLs. You don't want to run away like getting a bajillion intermediate representations. You don't want to run away that way.
Yeah, but like say 3 or 4.
Oh, only 3 or 4? You said stack like with your hands like this, so I thought you meant a million.
Okay, how about like 100?
Those are the two numbers. 4
100.
and a million.
100.
There are only 2 numbers.
And 28, 128 there. 2 is a number, 4 is a number, power of prime.
Yeah.
A million, no.
Yeah. So what do you want to do?
Let's see. Because we've both been flagging.
I mean, can we get? We don't want to do anything with property tests.
We can parse it because we can just import lean.parsec.
I figured they would. Of course, they call it lean.parsec.
Yeah, you can access the whole compiler. Just import lean.
That's so much fun. What is this, Lisp? What is it? What is this, Scheme? Yeah, Racket, right.
Okay,
Right,
well,
but what you want to do is you want to parse a string into one axis.
I'm about to abuse the fuck out of this.
Okay.
By just like adding this as a built-in method to string.
That's terrible. Or maybe it's not that terrible. It seems like it could be terrible. But how does it interleave the modules? Because we're in the namespace, the Einops namespace.
We'll find out, I guess. Here,
we're in the Einops namespace, so how does it interleave the module of like the string namespace if you're modifying the string namespace on the fly? The environment does not contain.
Okay, I guess not. Let's try.
I guess it doesn't work. Einops.string.parse. Einops.string.parse. But you can't eval Einops.
Yeah.
You're kidding me! You're absolutely joking.
Wait, why does that work inside of the namespace?
That should not work. That should not work. You should not be doing that. This is
String.parse does work, by the way.
Oh, it does work. So this actually, I can buy.
Yeah, this should work.
But you should not be able to do Einop.parse.string.parse. Why?
I don't understand.
I don't understand. You should not.
If you do underscore root underscore job in front of the string.
In front of string though.
Yeah, like if you define string.parse, then but like right now you define the function in Einops string.parse, right?
Yeah, okay. That answers one question I had, but not the question that.
Not the recursion question. This should be an infinite recursion.
I don't see the code over your picture. If you scroll up a little bit.
Oh wait, you gotta scroll. Yeah, because we're Einop.string.parse.
Let's make our picture smaller. We should keep your identity small and all that.
Okay, we can try it.
That's like the wasteland of the screen. Nothing happens there.
Nothing happens up there? Okay, you got it.
Yeah, so if you do the root thing, then like you can just write like as dot bars.
Oh. Taking notes for later?
Flashcards.
Flashcards?
Yeah, space
Oh.
repetition.
Oh, so that's how you write flashcards.
Yeah.
I need a better. I've been working like with Anki and stuff, and I've been like, I don't really have a good flow for writing cards quickly.
This is just like my notes as well, which is why there's no friction.
That's great.
It also is the only way I've ever found of actually ensuring I remember my notes.
What is it called?
Remnote.
Remnote?
One of its creators has been here a couple of times, because of course he has.
Yeah.
Yeah, Rem, like, remember. Okay, wait. Thomas, why does this work? Look, the eval inop.string.parse using string.parse when we're inside the inop namespace. How can it see itself from the namespace?
Wait. What's the problem here?
Like, here, let me see if I can replicate a simpler form.
Wait, I don't understand. What? You're
Hang on.
confused that the I know dot string dot parse.
No, that's not it. Hang on.
Yeah, we're confused at inop.string.parse about why that's not an infinite recursion.
Okay, this is what my confusion is. Look at this.
Does the indent matter?
No, it's just...
So b.c should work, but aa.b.c should not work inside of before you have end aa. So you should be able to eval aa.b.c. Yeah, see that would make sense to me. But why can you do it from the inside without an infinite recursion?
Why does it let you do it from the inside at all? Is this just some special case?
No, it's just the name, like, it's trying to resolve the name, right? If you're in the namespace, so when you define the b.c, you're defining something of a name aa.b.
Oh, yeah. This makes sense. This is not an infinite loop either. I think if I did this, it would be... Oh.
Well,
And then
it must be on the fly at runtime, like composing together the namespace and just not giving you any type checker guarantees about namespace. So namespaces are sections; they're not modules. So in Coq we have the module versus section dichotomy, which like, modules are like the strong type version, and then sections are kind of like very very different, and they let you like they're more like they're closer to namespaces, I think. I don't actually fully understand it myself.
no, like the namespace stuff is just kind of the name. It's just resolving the names, like the identifier you use for stuff. Like the namespace itself is not like some object that contains all the stuff.
Yeah. I'm gonna pace around in the back a little bit.
It's really, I think it works really like I don't know if you're familiar with C++, like namespaces in C++.
Oh, really? I'm not
Yeah,
familiar with any of the C or the C++ programming at
You
all.
stayed innocent of it.
I stayed innocent, yeah.
I see. Yeah.
I really dislike C++.
That's a feeling language.
No. That's like saying, like, you pat someone, you say it's okay when someone's died. And, like, I mean, what else can you say? But it's still not okay. Not really.
So yeah. Let's like continue. Let's stop goofing off with this
Yeah.
namespace stuff.
Parse ein.
Oh, can I just show you one thing that I was, like with the evaluation stuff?
Yeah,
Yeah.
sure.
There was
For sure.
something I was
Yeah,
doing, and
definitely.
maybe
Anything that improves the time.
you might find it interesting, and maybe it would be relate to what you were talking about. Right. So can you see my screen?
Yes.
Yeah.
Right. So like for example, one of the common operations in linear algebra, like numerical linear algebra, is this Sax-Fee operation where you take the vectors and you take a number, right? And what you do,
Oh, scalar multiply.
you multiply by a scalar the x and you add y. Right?
You scale.
It's like a fuse multiply add, but with vectors.
Yeah, exactly. But like the trouble is exactly right. When you write it in this naive way, then this is effectively two for loops because you have a for loop for the addition and you have a for loop for the scalar multiplication, right? So you really want to fuse the operations together. Right?
Yeah.
And most of the time, I don't know. Yes, I guess like you leave it to a compiler, but what I think is kind of cool in Lean is actually you can write out the definition of the function this way, right? And then, for example, here is a command rewrite by, and you can rewrite it to the form that it runs exactly just one for loop, right? So first, I kind of effectively like as I expand. Oh, it's too small, right? Oh. Yeah. Right. So.
Oh, I see.
Oh, you replace one expression by
I take
another.
this thing and then I replace it by kind of like as I expanding it, right? And then I just propagate the index access inside.
Yep.
And here now you're saying that, oh, I'm creating an array which has this thing, and this is effectively just single for loop.
Yeah, exactly.
Right? So the idea is exactly is that you write some expression in obvious ways, and then you can kind of at compile time or kind of interactively here in Lean.
In the tactic level, yeah.
In tactic mode, kind of rewrite it into more efficient. This can be you can still make this faster, right? Because here I'm kind of creating a new chunk of memory for these elements. So ideally, this would be rewritten like the map over X.
Yeah.
So like yeah, ideally you would probably follow this and make it look even a little bit faster. And maybe if you really want to go now for it, then I don't know, having some like SIMD operations, and then maybe you can rewrite it to some SIMD operations or something. I don't know.
I just imagine like a chain of rewrites that put into progressively more normal form, especially for optimization. You could also have one, say, for memory that will lift things to GPU level or off of it.
Yeah, for sure.
Yeah.
Use it sort of like Python's libs.
Yeah.
I would say this is definitely the most powerful, like, usable language I've used.
Yeah.
So I like this kind of rewriting. It's kind of you are familiar with the ESL halide?
The what?
I've heard of it.
Halide. It's a language or like DSL for writing exactly programs operating on tenders and higher dimensional arrays.
Oh, I never heard of this.
And the idea is that you write the program once in the most nice way, and then you just write a bunch of rewrites so that you get a more optimized version.
Yeah.
And they even have, I think, 1 year or 2 year old paper when they kind of did these transformation formalized in Coq.
Mm-hmm. Great. That sounds awesome.
But that's something that I would like to do kind of in Lean.
Halid. No, it's not that. It's not that. It's it goes into an H list. Here, we want our alias of H list to actually be to call it axis. Call it axes. Change H list to axes because H list is not a good variable name. And then actually parse ein is gonna return. Parse ein is gonna return.
I prove this because I can then just do this instead of saying axes. It's always a good sign.
And then. The return type of parse ein is an axis. Is an axes. Yeah. So A.axes should be, well, no, because you don't put the arrow in. We don't have the arrow.
Then this one will just fail.
It should fail.
Good thing there's a thing for that.
Check fail.
Yeah.
Well, it's not check failure because it should be a some act. It should be a maybe axis, or an option axis.
This is just one of the funniest errors. Unexpected success.
yeah. It should be none axes. Or it should be some axes. It shouldn't be.
I don't know why, but for me that
It's
was
funny.
the funniest.
No,
thing
it is
today.
funny. I'm not like knocking it. I'm not saying it's not funny. I'm just
Oh
saying
my
I'm
God,
like.
that's great. Oh, that made my day. Okay. A. Okay.
A.parsign should work, but it should return some, and it shouldn't. We want to do option. We don't want to do failure. It's not like Rust. We don't want to do like failure versus success. We want to do some versus none.
How do I attach a deriving after the fact to something? I guess there's already a repr for. I could just do the easy way and just enforce that alpha has to have a repr type class constraint, so that it can print out values and actually see them.
Yeah, you should. You should do that.
Where would I put it?
You would put it. Oh, that's a good question. How do you do this syntax with like two different? Nope. That's before the quantifier. Nope. Then you have a double quantifier. Then you have a shadowed quantification. It's bad. We need enum type to have. Here's what you want to do. You want to define a new type class that's just a union of the two type classes, repr and enum type.
Is there like a less ugly way?
I don't know. There might be. There might be a way to constrain enum type with. It's constrain alpha with two different type classes. No, that's not it.
The shadow thing.
That does the shadow thing because remember, so that quantifies it like a for all, right?
Oh,
but on the right hand side,
for all of it there exists.
On the right hand side, you're quantifying it with there exists inside the list.
Yeah. Okay.
Ask Thomas. Thomas, how do you do two different type classes in this alpha?
Or you can just write another cross. No?
No, I don't want to write another. Oh wait, yeah, enum type alpha and enum. That would sort of work.
It's a list of not tuples but triples where you also for each alpha store repr. If that's what you, I'm not sure if that's really what you want, but
This might work.
you can do that.
This could easily work. I don't know if it's that hacky.
I'm not sure what you're trying to do.
We're trying to we're trying to extract from a string that is just a list like A or AIIJK. We're trying to extract the indices from that. So what we want to do is we want to say IJK like it, or wait, hold on. This is hard. Hold on, I'm confused now. Because we don't actually know what I and J are as numbers. So we need to do like more existential types or something. Oh wait, no. It's just we're trying to turn a string like IJ into a list of axes that's like the same thing. That means the same thing.
Couldn't we just do 0 and 1?
No. Maybe. No, that would give us problems later computationally.
Why?
because if later they weren't 0 or 1, then we wouldn't be able to compute. I think.
I'm confused. What does the axis supposed to represent?
Axes are basically axes. That data structure axes. That's literally like the shape of the tensor.
Okay, fair enough. Yeah.
Right. So typically a tensor shape is just a tuple of
The dimension sizes, right?
a tuple of sizes of the tuple of dimension sizes, right? But we're doing it as a tuple of the actual IDX enum types.
Yeah.
So wait, I've been telling you, dude, it's gotta be a sum axes, because if they do something illegal, no, sum is an option. Option. What's option? Is it maybe? No, it's option. Is it optional? I think it's optional.
No, it's optional.
Okay.
But then I have another question. Like, then effectively you're indexing the tensor with element of a product of all these index types, right?
Yes, pretty much.
And that whole product type is enum type again. So why are you using this like in this representation, right? Effectively you have the rank very explicit. If you would work with the whole product of all the index types, then it's not even that clear what the rank is, because sometimes you can understand rank 3 as a rank 2 or something like that.
Well, that's true, but
typically, like in a given representation, people care very much about what the exact shape is, and that it has an exact shape to the point they would consider it lacking one to be an error in the idea, really.
Yeah. I think so. I think that's basically true. Also, I guess I'm wondering if this is like...
telling someone a tensor doesn't have a shape would be like telling them the addition of numbers is like not supported by set theory. They would just throw away set theory first.
Yeah.
So, like, to me, the shape of the tensor is given by some enum type. The rank of it is not, to me, the rank is not well defined in that. I
think that's a really interesting view. Tell me how the enum can be the whole shape, because to me an enum is just one dimension of a shape.
No, right? If you take a product of enum type, it's an enum type again.
Yeah, that's true. So
right?
Yeah.
And then rank 10, like rank 10 tensor to me is effectively like a product of 10 different enum types. The thing is that somehow there are some convention how you bracket it, right?
Well, that's true. And if you have introspection, if you can inspect like the tuple structure and infer things about it, but if you just erase all the tuple structure and just replace them with labels, which is what enums are supposed to let you do, then you don't get full rank, like all the information of rank, or all the information of shape rather, out of one enum.
People would not throw away that information. That information determines its performance much.
But the enum type class, it's supposed to let you throw away that information, or else it's not an enum type class.
True.
To some degree. This might not be like a productive way of working, but like it is like abstractly, it's a valid way of thinking. So wait, you put the inductive before the namespace.
Yeah, I just.
Okay, I guess that's very different from anything that's in Coq then.
Why?
Because you would just never do that with a section or a module.
Name them the same thing like that and not put one in the other.
Yeah, pretty much. Or one thing that's popular in OCaml is to actually name your module with the descriptive nice variable name, and then the type inside the module is just called T. So in OCaml you would do like nice descriptive variable name dot T is the name of your type. And like Coq inherited some of that, but it's like less extreme, usually stylistically.
I don't like that.
What is this? This is just cool back here. Anyway. There's like a little case there.
Yeah.
Okay, so I basically buy this. I'm a little confused about what we're doing right now, because the reason I'm confused is because we're trying to turn labels for indices into values of indices, because we're trying to construct an existential sigma. We're trying to construct an actual sigma.
Okay, how
out
about
of just
instead
a
of
label.
going from type level, value level, come up with one example in a comment and go from there.
What do you mean example? Of a string to parseine. Oh, okay. So type parseine. Yeah, parseine.
Yeah.
And then quote A, quote or I. I would be more traditional, and then equals. Singleton list.
I just thought it was very satisfying.
This is the tokenizer idea.
This one is actually just when I did the typo where I put an extra space after.
Yeah, you remembered.
But then I thought of a way, because normally remembering to normalize stuff is a pain in the ass. But I'm thinking of using the coercion system for
Oh, I know what to do.
it. What?
You can't just parse a string. You have to parse a string with respect to a particular array. Yep, I know what to do.
Okay.
I know what to do.
Or at least its shape, but whatever. Array, we can abstract that later.
Yeah, exactly. Array shape. We give it a particular array, and we say, if we do a validation, like parseine array I is going to be singleton array.length.
In that case, parseine, since it should take the array.
Hold on, wait. Finish writing the unit test. Parseine array equals singleton list array.length.
Something array.length. Index array.length. There. Something like that.
Yeah, something like that. So what this does is it assumes that array is given it to be one-dimensional. It assumes that array is given to be one-dimensional, right? So we need to put in validation for that. We need to put in validation that the number of unique characters in the input string is equal to, right? So this exactly do that, but then in IDX, like get one or the other. See, this is something where the nice functional model where it's functions from index sets, the nice functional model of arrays where they're functions from index sets. This is where it would break down, because it would be really hard to do this, because you can't inspect an array and say, give me the type of your second input.
Yeah.
Give me the type of your second argument from the array. This isn't Python. This isn't JavaScript. You can't do that. I don't even think in JavaScript you can do that. In TypeScript you can only do that if you want to. If you go out of your way to make sure you can do that. In Python you can just do that, I think.
How do you feel about TypeScript structural typing? I've never really used a language that's embraced it.
I don't know what that means.
Like the compatibility with key fields, there's not that much of a difference between their interface and struct, or class as they call it.
I still don't know what that means. I think you're at 27% battery.
What?
You're not charging.
That's false.
33%. Oh, that's not the battery. That's the CPU usage. My bad. I'm dumb. It just looked like battery.
A little flicker from battery to go 5% up or down every couple seconds.
Yeah, that would be weird. Ignore me. I'm dumb.
Okay, well, we parse and then we should get maybe some axes. Shouldn't we always get some axes even if it's empty then?
No. Einops fails.
Oh yeah, because they could fuck up.
Einops fails if it's given wrong stuff. It could be a result instead of that, but you need to give error type though.
Yeah.
Result
I'm
has
just
2
gonna
arguments.
I know. I'm just gonna use a string.
Okay. For now, stringly typed.
Alright, should be array of. Is this thing typed?
Wait. X is what type of arrays are we using right now? Scroll. It's all the way up at the top, I think. Or I think it's still array dot. Is it ND array?
Data.
Is it data array? Is it or there's one more? What's the other one? The one that's commented out though. It's not the one that's commented out. I guess it's probably in data array then.
Array to subarray. Oh, this is just a regular array.
Okay. So what you want to do is you want to say, presumably this is a standard parser combinator library, right? So I've been trying to remember how parser combinators work. I haven't looked at them in a while. In a parser combinator library, what you would do is you would let's just write up a description in pseudocode and ask the AI to do it.
Okay, say it again then.
Okay, so what we're doing is we expect S. Okay, so that's all context, right? Add to chat. Implement with parsec. No. We're gonna describe what Einops. Oh no! Don't go that far. Don't go that far.
Why shouldn't I?
I don't know because I wanted to describe it at least.
And even auto indexes really implement the green compiler parsec. I know at least one person, if he watches this, Michael, will be absolutely horrified by this or feel vindicated. But I feel fine.
I don't know. This is so.
I don't know if it'll work, so we're gonna find out. Now we can describe Einops syntax anyway, though.
Is it working on it right now?
Yeah.
Okay. So this is going to be take a string. This is simple though. This is because we're only parsing one axis. In fact, call it parse axes. Parse axis. Or parse axes rather. Because we're only doing left hand side or right hand side right now, and we're writing only the module that will be the shared code between left hand side and right hand side, right?
Yes.
So it's going to be parse Einops syntax. So take the number of unique tokens, where tokens can be like either just characters or like strings like time or channel or batch. You know what I mean? Unique words separated by spaces. And return sum of. Well, first you should be able to convert a shape to an axis. Well, we already kind of are.
Extract unique words. Take a string,
That's fair.
split it on strings, erase dupe. Okay.
So parse axes.
Can you do a nested def? Is that a
Maybe. I mean, you can do a let lambda. You can do a let with a lambda, right? You gotta be able to do a let with a lambda in the middle of an expression.
just So that works.
And all you're doing, it might be best to actually convert an array shape into an axes element.
Oh, you'll like this little syntactic convenience, by the way.
Yeah, it is. Oh, that's wait. What
It
is
has
that?
a dot afterwards too. This is equivalent to doing. It's when you're calling a bunch of dot methods on the same thing, which is
Yeah.
pretty often. Because this thing on the left side is also a list, and then it's being called to list.arrayStup. One, you don't even have to write that if you can just do a dot. If it can infer it from context, it will.
That's nice. That's really nice. I like that.
And it will
a
like
lot.
reach in.
I can whip that up in Cock, but it would be a custom layer that I made. You know what I mean?
No, but I can imagine the difficulty.
It would be a pain in the butt.
Yeah, well, this is just like a thing. Swift does a weaker version of this, I think.
Cool.
Lean really likes to make everything implicit,
Yeah.
and you can just go farther and make it a full operator like that.
Okay. So, oh, it's fun. Does fun let you do that?
The fun is just the lambda keyword.
Oh yeah. Okay, so here's what we need. We need. Let's instead do a list of an array to axes function, a function that just converts an array into axes.
Oh,
And-
it actually should be.
And what this does is this gets us back into the data structures that we were looking at earlier, like way long ago. I would just put this function out into a separate utility. Yeah, and then just erase it from the inline. But also, what we need is we need to convert an array into an axes. So what we want to do is we want to extract all of the enums from the array data structure, all the enums of its shapes,
So,
if we can.
So last part again.
Its shape is a list of enums, right?
Yes.
We want to just return axes. We want to make our axes data structure work with the array's shape.
Oh, okay, so let's return something.
So what's going to happen is, if extract unique words length equals, convert shape to axes length, then do sum
Say if what? Oh,
if extract unique words dot length.
well, if they're not equal, then something's not found.
Some axes not found, or maybe there were too many names provided. No, just do not equal. Just do not equal and say some axes they don't match.
Some axes not match.
Oh, you already did this. Wait, was this just AI?
Yeah.
Words dot map. Why would axes dot?
I don't know. That one is just doing. Let's say, is this meaningless?
Well, let's try to eval.
It has debug trace.
Oh wait, you gotta do okay axes. Axes arrow okay, or result dot okay, or
Yeah.
something.
Function expected result.
Yeah, you said result, so it's gotta be result dot okay.
Is it not called this in Lean 4?
Oh, what's it called?
It's a Google.
Oh, Moogle? It's like Google, but for Lean? That's amazing!
There's also Loople.
For Lean?
What else? Yeah.
Moogle and Loogle.
Oh, this
Yeah, Google is just simple search. Oh, just search. And Google is some semantic AI stuff.
Oh, I see. Do they have a Hoogle? A version of Hoogle?
Loogle.
So Google is Google. Yeah.
Lugal is Hugel. Okay.
Yeah. Moogle is some AI powered stuff.
Cool. Oh wait, so they have a parser error.
Does Lean not have a canonical result type?
Oh, what do you mean by result type?
Oh, I think this is the one I'm looking for. Except.
Yeah.
That looks like
And of course, instead of saying error, it uses fucking epsilon.
Yeah. It's the fascination with the Greek alphabet is a bit odd.
Okay, so do accept instead of error.
Leo's
but,
not
but
even from Greece.
it does use okay.
Mercifully, yeah. Alright, well, that mostly fixes it.
Oh, it puts the error type before the.
Yes, it mentioned that too.
This is the wrong implementation, though, I think.
Yeah. Okay, we have the words.
Can you do hole driven development like in Agda?
No.
In Lean? You
No,
just can't.
I don't think so.
That's a shame.
It'll come. Like,
Yeah,
Lean's big advantage here is it's
there
fast.
is the e-state monad, and there is an e-state m dot result. So that's kind of way to do. I don't know if you want to do exceptions and stuff.
Oh.
Hold on, wait. Do accept dot error, not result dot error.
Oh, that.
Oh, you can do that?
Yeah, well, like in any context where it's unambiguous.
Oh, cool.
Okay, now let's give it an actually correct implementation.
Well, we'd have to look at the data array type, which is not signatured correctly anyway.
Yeah, this is supposed to be some A that's a plain data type.
Yeah, so the data array is compactifying like the bytes and stuff. Because if you use the Lean normal array, it's just continuous array of pointers.
Right.
So data array is but it can store only stuff that has like a fixed byte size. So that's the plain data. I think in Haskell it's like storable or something like that.
Oh, right. Makes sense.
Yeah. So in data array you can store like floats, you can store fin n or stuff like that. Maybe not fin n right now because that just doesn't have the type class. I think you can store like in idx and I think you can store u size or something. Yeah.
Oh, right, there's no axes. Okay, we've got all the unique words, so let's see.
Alright, so
Let's just like do a running example too. Should I guess just do a bunch of debug traces.
Ooh, debug traces. I'm learning so much about Lean.
Exclamation mark. No, it's just debug trace.
Well, you could use that for hole driven development. Right? You could use debug traces. It's not quite the same thing, but it's very similar.
Okay, let me set up all these examples then. And I'll leave it right too.
Oh, you have code QL CLI too. Is that like part of the? You have code Q is like an extension, like in. I didn't know there was an extension. I just used the GitHub action.
I don't think I've even used this ever.
Yeah.
Also, dude, I really need this elaboration function.
What elaboration function?
To
Oh.
be able to write an array literal.
Yeah.
No. Actually, I'm a little surprised that this syntax wasn't implemented. I guess you could add it on.
Yeah.
Kind of funny. You can have like a wish list of syntax that you can just like go through and just make.
Mm-hmm.
All right. Well, what's another way to do this? Hey Thomas, give me an array. I need to come up with an array.
Oh, just like 0, 1?
Yeah, but if I try to actually literally write 0 and 1.
Oh. Well, there was something in the example that worked.
With that? Oh, it just needs to have length more than 1. Oh, right. It only we discussed this last time. There's an issue only if it's a singleton.
Oh.
Whatever.
Oh yeah, sorry, I was going. Yeah. I think we found out last time. You found out that if it's just list of one element, it doesn't work. So you just write. Yeah. It's based on the first element. It decides the type. So right now you cannot. Yeah. Before that you had the 0, 1, but 0 is by default is net, and because net is arbitrary size, then it's not plain data type because it's arbitrary size. So you cannot really store. You cannot store natural numbers in the data array.
Yeah, the sizing because it's arbitrary precision.
Hold on, is it X's? Is it... No.
Oh, okay, it's the whole thing. Silene.data array n.
I think because the data array is like silene dot the data array, so you probably I don't know.
It must be
Or
explicit.
it should also be .n. Yeah, I don't know in which namespace are you in right now. If you're in the
No, I'm
Einops.
not. Namespace even closed.
So you should silene dot.
Just kill the namespace for now. I don't really need that.
Do you want axes.size or x's.size? You want axes or...
No, I don't want axes. That size definitely not.
Yeah.
Yeah, but axes and size, I need to define what the axes are. Or length or whatever.
Yeah, it's the length of the shape.
Also, the issue is that the parse x is
Why did it list length and not size?
it is a namespace data array n, but it accepts only data array. It does not accept data array n.
Oh, right. What does data array in? Still plain data type. It also needs this thing of iota. That's an index. What should this be? Should I just leave the indexing type also generic?
Yeah, now you have to provide like some generic index type. Index type.
It's not. Oh, just index. Thank God someone spells the whole word out. Oh. It is the wrong order. Yeah, it's A then the index.
I think you wrote it. I think it goes in the. Oh, it doesn't. You have to go.
Luckily the types don't. Axis is the type axis. How the hell? Oh, it's they're doing like some bidirectional inference. What if I like comment this out? Yep. That's satisfying. A little freaky, but satisfying.
Bidirectional inference? What do you mean?
Look, if I... It knows the type of axes, even though I haven't told it anything, really.
Mm-hmm.
Up to this point.
Yeah.
Because I can infer it from the if branch after.
Uh-huh.
Because I do okay, and that fixes the type.
Oh yeah, bidirectional inference, totally.
Oh. Axes dot light.
Yeah, I mean that makes sense. But that no, it doesn't because. Well, yeah, it does. We're just. And then what you want to do is you want to. Let's put that into its own function where we just look up in the data array where its shape is stored and how it's stored. I don't really remember because it was like hours ago.
To get the axis?
Yeah.
Okay. Get axis. And let's see.
Get axes.
What do you need to get them out?
We need to look at. Let's just look back at the code of where data array is made. Data array, probably. Maybe it's in backend.
Silene.data.data.array.data.array. That's one to be. Okay. Interface. Quotiented by trailing bits. Nice. Yeah, this is the one that wraps a byte array.
Okay, so is it? It's not. No. The data array is not the one we want then. I always forget what that key binding is in my Emacs, and sometimes I hit it accidentally.
Currently, this is inconsistent.
What's the name of the other thing? It's like one level higher than this.
data array n, I think. Actually, that's a array. Data array n might be defined.
Might be lower.
No, it can't be. In Lean, everything is parsed strictly top down. I think all their improvers tend to go this way.
That's what I mean. Well, I think we're just switching the word for higher and lower. I meant high level of abstraction versus low level of abstraction.
Oh. Data array n. Okay, data. You can get the size, but of course, from the way it's set up, only the full length.
No, we want the size of it. We want the... Hold on, data array isn't low enough because remember all this stuff with the stride? We didn't have stride.
Yeah.
Don't we want to be doing this on collections?
Higher up.
Because we don't have stride, so... Oh, man.
Wait, so do I understand it correctly? So you want to get the individual sizes of each dimension?
Yes.
Right. Yeah. So that you really right, and you're confused that you don't have access from the index type class or something, right? You don't know like what is the rank or something, right?
No, like, you're just given the array.
If you're given an array, how do you get the size of the... How do you get out the list of IDXs?
This is the but it's not representing that.
You cannot, right? It's kind of it's indexed right now. The data array n, right, is indexed by this type iota, and you don't know anything about it.
Okay.
Right.
You don't know anything about it. Do you know it's at least an enum at all?
I don't think that.
Yeah. For example, right, like the iota can be, I don't know, it can be binary trees with maximal depth 10, right? That's a finite type, right? It can be, you can index that with like, I don't know how many binary trees are there, but it's, right? You can imagine you can have data array that stores a value for each binary tree which has depth maximum 10, right? So there is no notion of rank for that kind of index, right?
I think we might have to have a different underlying representation than really mimicking NumPy or binding it. Binding NumPy, or better yet, something like JAX would probably be the most useful.
It would, yeah.
Because then that would immediately make this usable for deep learning.
Yeah.
And then you could just build on top.
It's true.
But what you want is, it can be done like on the level of, for example, our operator. Is that when you get the exact type index, you can kind of look at it and then check if it's like if it's a product of multiple types. Like is it a product of just like fin n, and then you can extract all the n's and you can get the rank of it or something.
Okay.
Right. So like here this is extremely general. So just you can have data arrays. You can have arrays indexed by something extremely arbitrary. I guess what you want for deep learning is that you can index only by kind of products of fin n, and then you have like well-defined rank. You have well-defined like how many dimensions you have and what are the dimensions. Right?
What does JAX do for indexing actually? They tend to strike a good balance between generality and specificity.
Well, I think, you can... No, I think that's...
Yeah.
I think what you want is that one thing you can do, you can build extra type class, which specifies the index type class, which is more general, or like more specific, and really kind of supports...
Oh, I see, and just use the type class resolution and specialization to get it.
Yeah. So, for example, you would create a new class which is called like a tensor index, right? Which has well-defined range, and you can kind of get the individual dimension of each, like the sizes of each individual dimension, right?
Mm-hmm.
I think that would be the approach.
That's more appealing. So.
Okay, I like that actually. I mean, we gotta.
Yeah, because it takes the advantages of both.
I'm running out of juice. I'm like getting a little dazed.
Same.
Right, so
Jesus Christ, how many jumps did I make? So what, a new type class of like actually I will call it ND array. Thanks to NumPy.
Did we already call something ND array that we copied over from the unit test from earlier?
Yeah, it's right here. But it was just wrapping a raw array, which isn't that helpful.
Yeah.
Alright. If you hold shift on something, it tries to figure out what it does. Not very well, for some.
You're missing a prime dot size up over on the right.
That's not the only issue.
Yeah.
Actually, never mind. Okay, this was the one I was looking for. The syntax was just creating stuff by specifying basically a fancy map.
Yeah.
Also, before IJK, I like to go with like row and column.
Oh, literally just the words row and column.
Or R and C, but yeah.
Yeah, you're right. The way you do when you get the Z.
D. For D's nuts, but no for depth.
Depth. Yeah.
Okay. What's in our ND array? Something that's also a data array.
I think it has a data array as data, and then it has a shape that it stores as constant. That it keeps updating and everything. That's how NumPy does it.
Data array n. Failed to synthesize an instance.
I've sent you a class called ND index.
I see. Thank you.
There you go.
What? Class and the index of iota extends the index of iota where rank is a natural dim is a map from rank.
Right, that's what you want, right? You want like the node rank, and you want the node the individual dimensions.
Oh.
Yeah.
Oh, would this just be like the sum over the dimensions then, the shapes? Or, oh no, just like the length rather of the list.
The length of the list of shapes. Yeah.
So, right. So instead of if you expect instead of the index type class, you require the ND index, then it will kind of tell you the shape of the render.
Yeah, this makes sense.
Should be dim or dims.
I think it should be dims.
Okay.
But I'm starting to lose my noggin here. I'm like, I ran out of juice, so maybe I'm just talking nonsense.
Okay. Instance of ND index M. Or okay. And then the product. Yeah. Nice.
What does the angle bracket do?
It's the anonymous constructor, like the Bracey constructor that I think in C++.
Yeah.
Oh wait, yeah, you wouldn't. If the type can be inferred, it just lets you pass in the arguments to it to construct like whatever type.
Yeah. So in this case, I use it for like fin n is a pair of the value and the proof that it's the value is actually smaller than n.
And then of course the sorry, because who wants to prove that? Yeah. And okay, nice.
Sorry is so funny, isn't it?
Yeah.
It's like,
Does any other
I'm
language
sorry.
have that?
I don't think so. I mean, Python has it. You can do whatever you want in Python. I mean, it's not like sorry, but it's like, none or pass. Pass,
Yeah,
I'll pass. You know what I mean?
Except pass is something totally different.
Then sorry.
Yeah. Sorry, if anything, is like erroring out. It's not erroring out, in fact, it's quite the opposite, but
Yeah.
we have a shape which should be an ND index. Where's the invalid? Oh, yeah, that was it. That's more like it.
I mean, Coq doesn't even have an equivalent to Lake.
Of course not.
You're
That's
literally...
like beneath them, and that's the problem.
Dude, Coq should have Lake.
My argument for lean is like why I like Apple in a way by analogy.
It's
'Cause,
by
like,
now. I noticed that earlier, yeah.
Yeah, that it's like Apple's not really a hardware or software company at this point. They certainly do both, but the point is that they braid them together,
Dude, Lake is so good compared to what you do in Coq.
which is what like copy paste.
I just copy paste like initial config, yeah.
We still need Lake add. The Cargo only got Cargo add relatively later, and Lake probably has some magical facility for adding subcommands because it's pretty magic. Much like a magician.
Maybe I should just make a Coq like,
No.
template
Why would you do that?
to do something for the community for once, instead of navel gazing nonsense that goes nowhere.
I mean, more like
For what community though, right?
yes, that's exactly. Right.
Coq is already such a small community, right?
Unexpected token. Like, what do you mean failed to synthesize? It says it's right there. Any idea what's up here?
Dude, I got like no juice left, dude.
Okay.
I mean,
Let's see.
Yeah, I'm dead.
Alright, we're calling it then.
Yeah. Thomas, I think we're gonna call it because like I'm dead. I'm like dead tired at this point. Well, don't leave call. We gotta, you know,
Oh,
we
yeah,
can turn
so-
off stream. All right, bye everybody.